Okay, so let me introduce our speaker for today. Dr. Christa Peters-Lidard is currently the Director of the Sciences and Exploration Directorate at NASA Goddard. She has been the Deputy Director for Hydrosphere, Biosphere, and Geophysics in Earth Sciences Division. She's also been the acting Goddard Chief Scientist for a time, and she was a physical scientist in the Hydrological Sciences Laboratory. She knows a lot about water. Her research interests include land-atmosphere interactions, soil moisture measurement and modeling, and the application of high-performance computing and communications technologies in Earth system modeling. And for that, her Land Information System team was awarded the 2005 NASA Software of the Year Award. So she's very proud of that. She's won a number of awards. I'll cite just a couple of them. She is a fellow of the American Meteorological Society and also the American Geophysical Union. And in 2023, she was elected a member of the National Academy of Engineering. So quite an honor for her and for Goddard. Her PhD is from the Water Resources Program in the Department of Civil Engineering and Operations Research. You're an engineer.
I am.
At Princeton University, and she has BS in Geophysics, summa cum laude from Virginia Tech. So please welcome Christa. She'll tell us what's next for Science at Goddard.
A special invitation to an event coming up at the end of the month. Okay, so mic is working well. Great. And there we go. Okay, so as Carl said, I've been at Goddard for quite a while. I've been at Goddard since 2001. And it's been a great journey. And one of the things that excites me about my current job is to learn new things all the time about our 4 science divisions. So if you haven't looked at Goddard in a while, just to remind you, we have 4 science divisions, and I'm going to tell you a little bit about what's next across all of science at Goddard. So this is something that McKinsey has really been driving home. Sorry, blocking from this side over here. So which is that we begin and end with science. But that doesn't mean that it's only science. That means that in order to execute science missions, we have to conceive them, and a lot of that work happens in 600. But then we partner with engineering, with flight projects, with safety and mission assurance to actually execute those missions. And so this is the life cycle of missions. That's what this is showing. So designing, building, integrating, and some of you, I'll talk about Roman in a minute, but we're right in the midst of that. Of course, testing and launching. And then, as a scientist, we get excited once something launches. Like, everybody's so focused on the launch, but actually, it's when the data starts coming that really delivers the science that then leads us to the next mission. So, within Goddard, we have, those of you that left before McKinsey know that we now have changed our new business areas to be called strategic focus areas. So, Goddard's not a business, but we do have areas we focus on, and 4 of those are in science. So Astrophysics, Earth Science, Heliophysics, and Planetary and Lunar Science. So those are the first 4. And then, of course, these foundational COM and NAV, Crosscutting Technologies, and Suborbital, which, of course, a lot of the suborbital work ultimately leads to new missions as we advance technology readiness levels. So how many of you have heard of Goddard 2040? Some of you have, right? So when Mackenzie Listrip, our center director, came on board, she put forward, she worked with the leadership team, and we came up with a vision for Goddard in 2040. And what we did was we defined 7 vectors, which basically, as you all, many of you are technical, so you know that a vector has magnitude and direction, right? So what the point of this is, when it's a vector, it means you're pointing in that direction and you're putting certain effort into that to get to that vision in 2040. So advancing multidisciplinary space science is vector 1. That's a big focus. That includes things like building instruments that will ultimately be on any, many different science applications. Searching for habitable worlds. So many of you have heard about the Habitable Worlds Observatory in Astrophysics. I'm going to talk about it later, but that's searching for habitable worlds is more than just building that observatory. It's actually understanding the science and what it takes to find, evidence of life. Indicators as well, looking at astrobiology, planetary atmospheres, and exoplanets, and other things. Vector 3 is about serving as a hub for Earth system science. So this is basically, many of you know, Jim in particular, Jim Myers, our former Earth Science Director, knows that NASA pioneered Earth system science, and really a lot of that happened at Goddard. And thinking about the Earth as a system requires that you not only observe it using different frequencies and different techniques, but also that you integrate the data with models to try to understand the connections between different cycles on Earth. And so being a hub means that not only do we do the science at Goddard, but we work with the broader community. And many of you, if you're following where Earth science is going, the commercial sector in Earth, in remote sensing, has taken off. So things that used to only happen at NASA now are commonplace in the commercial sector. Starting with the originals like Planet, Maxar, their digital globe products and so on, but it goes way beyond optoelectrical. Now it's SAR. I mean, there's commercial SAR. There's just about every technology you can think of. There's now a commercial equivalent in Earth science. So integrating all that is now the future, not just doing one-offs that happen in government. All right, so vector 4 is about space weather and advancing that. So heliophysics is the science of the sun, but really the space weather part of it is the application. So being able to take what we know about space weather, what we know about coronal mass ejections from the sun, and being able to predict their speed, their arrival time at Earth, and then the impacts not only at Earth, but now in cislunar space, right? Because as we're traveling for Artemis, we're going to have to be able to protect assets on the moon, at Mars, and wherever. So that's kind of where vector 4 is going. So it's really about a much broader purview of space weather and really applied heliophysics. Vector 5 is about partnerships. So these first 4 were very technical. Okay, the last 3, 5, 6, and 7 are more foundational, right? So it's vector 5 is about partnerships, collaboration. So so Carl mentioned social media. Definitely, I hope you follow us on LinkedIn because we're doing a lot with partnerships. I just signed an agreement with Columbia University. So many of you know we have a long-standing Goddard Institute for Space Studies in New York with Columbia. That partnership expands our connection with Columbia to go beyond Earth science. So now it's going to be across all of these vectors. We're signing agreements with other entities as well. We just signed one with University of Colorado, LASP. They're really experts on CubeSats and smallsats, which is another area where we have to decide when do we build things in-house and when do we work with a partner. And we're really leaning into thinking about what is core to Goddard and what is something that might be best done through a partnership, and how do we bring the best of both worlds together. a culture of inclusion and curiosity. So, this one it sort of goes without saying that, as scientists, for us, we're naturally curious, but curiosity here is about intent and about making sure that you have valued and diverse opinions. When you're on a team, you need the unusual suspects to speak up and bring the good ideas and to call something to your attention that other folks might have missed. And that's what I think, that's like the promise of having, teams that are inclusive. And then modernizing our campus. So many of you know, what Goddard's facilities are like. And by the way, I hope, many of you have badges, but, I think Carl's going to be working with you all. If you don't, there's ways to sponsor for badges. But, it's interesting when you come to campus, we have some very nice new buildings that are lovely. Like, we're building parts for one of the new missions I'm going to talk about, Dragonfly. But there's other buildings where the roof is leaking. And, we had a National Academy team come visit. So many of you have heard of the Crossroads report, NASA at a Crossroads. If you have not yet read this report, I really recommend that you download and read it. It's about all of NASA. It's not unique to Goddard. But it's about the idea that infrastructure at the NASA centers has waned over the years. There hasn't been enough resources to support maintaining or operating infrastructure while we're trying to do all the missions we want to do. And so that report, that committee came to Goddard and we gave them the underbelly tour. They saw everything. So, when they wrote that report, it was kind of refreshing. Like they got it. There's some things in there that are controversial, because they've said, maybe NASA needs to do fewer missions to bring its infrastructure up to speed. And that, I think, is still being, so there's going to be a response from headquarters. So it's not up to Goddard to respond to that report. It's up to headquarters. And there's going to be an official response sometime in the middle of this calendar year. So look for that as well. But I encourage you to read it because it's really about the future of NASA. And the lead author is Norm Augustine. So some people call it the Augustine Report. Anyway, so those are our vectors. That's sort of where we're going long term. And, I think in each one of these areas, especially in the science areas, we've been working on plans to implement, how do we get there, in specific steps. But I'm not going to focus on that today. I think what I wanted to do, I wanted to tell you about our, when you say what's next for science, it's really about what's next for Goddard. But now I want to kind of shift gears and really focus on what are the missions that are next? And where are we going with different missions? So I'm going to go through these in more detail, but just to give you a preview, in astrophysics, Roman, if you have not been to Goddard lately to look in the large clean room over the overlook, I highly encourage you to do that in the next few weeks because everything's been integrated. It's amazing. This is a perfect time to come see Roman. I'm going to talk about Hat Worlds, Lisa. There's some other things I'm not going to talk about, but there's a lot happening. In Earth science, we're working towards Landsat Next. We're working towards the Earth System Observatory, hopefully the Atmospheric Observing System. We work with our partners at NOAA. GeoXO and NEON are the two new geostationary and low Earth orbiting programs. And then Earth system modeling was a big deal. In heliophysics, we've got a bunch of launches coming up. IMAP, well, that's already going, but Punch and Tracers. Parker Solar Probe just had its closest approach, so hopefully, Christmas Eve, I don't know, how many of you were aware of Parker Solar Probe at Christmas Eve? That's good. There was a lot of press about this, so that was a good thing. Even one of my family members, like at Christmas dinner, was like, "Hey, what's up with this probe going into the sun?" I was like, "Oh, you heard about that?" It kind of surprised me. So anyway, so it's good. And of course, the solar maximum. So I don't know about you, but well, how many of you saw an aurora this year? Anybody see the aurora? It was like visible here in the DC area a couple of times, which was amazing. So Planetary and Lunar Science, Artemis, OSIRIS-REx, there's going to be a huge press conference soon. We've got some flybys for Lucy, and of course Dragonfly and Da Vinci, and lots of other work going on at the range in Wallows. So let me get to Nancy Grace Roman. So this is, if you can't make it to see it, here's some pictures. The spacecraft and the telescope have been integrated. They call this the SKIPA now, and it's great. It's been a journey. Roman is on time, on budget. This is really critical for Goddard to deliver as committed to. So, you know, the launch date is no later than May 2027. So that's the official word right now. But who knows? I mean, it should be ready by 26. So if we stick to our current schedule, which would be also amazing. So this is, there's a lot of sessions this week at the AAS meeting on Roman. There's a town hall tonight. I think what's really different about Roman is the data volume. So the data volume for Roman is going to be more like Earth science data volumes. And so, and beyond. And so that all of the processing now is being done in the cloud. And it's being, there are community-driven surveys. So it's not like you just, each person applies to get time to do their thing with Roman, like you do with JW, ST, or Hubble. It's going to change the way astronomers do science with flagship telescopes. So that's Roman. There's a lot happening there. It's going to tell us a lot about a lot of science. Here's some of the science it's going to address. So gravitational wave counterparts, which of course will go well with Lisa, which I'll talk about. Dark matter is a big deal for Roman because when you do these surveys the way that they're going to do them, you're going to learn about dark matter in a way that you could not do with any other instrumentation. There's going to be a lot of planetary system surveys. So, you know, if you look at exoplanets, what you do these days is you look for populations, right? So you look at, you know, Jupiters, like hot Jupiters, or you look at rocky planets, and so getting data of for those populations helps us to search ultimately for habitable planets, but it helps us understand the evolution of those solar systems. And that's a big deal. Populations of you know, and really answering big questions about the evolution of our universe. I mean, there's questions right now about the Hubble constant and, you know, some debate. And so this is going to be an amazing flagship for science and astrophysics. And it's going to feed us into the next flagship, which is the Habitable Worlds Observatory. So, so not everyone here is from science, so just to give you a little reminder, the science priorities at NASA come from reports that the National Academy produces called Decadal Surveys. So this may be familiar to some of you, but the reason they're called Decadal Surveys is they do them every 10 years. So every 10 years, they do a new report and recommend different pathways for science. So there's one for astrophysics, heliophysics, earth science, and planetary science. So Habitable Worlds was their big recommendation for in the astrophysics decadal. Sort of what's the next big flagship after Roman. There's also probes that were recommended. I'm not going to talk about that today, but we have 2 proposals that are being, that got through step 1, and one is an infrared and one a probe, and one is an X-ray probe. But for HabWorlds, the key is really trying to understand what where life might exist in our universe. And so that means looking for what we call biosignatures. So this is, I think, the next big deal. So for Webb, we're doing spectroscopy now. And we're understanding the composition of atmospheres, which might contain oxygen or water vapor or other compounds. And the next step is to actually look for signatures of life. And so HabWorlds will be, according to Mark Clampin, a segmented telescope with a coronagraph that is modeled after the Roman coronagraph. So the Roman coronagraph is going to be a pathfinder for this. And the Webb segmented telescope is a pathfinder for this as well, except it needs extremely tight control, ultra-stable structures. And so people like Lee Feinberg are working really hard on that right now, if you know Lee. So there's a lot of technology that needs to develop, and this is one of the big lessons learned from Webb, is that if you know the technology gaps now, you've got to work them now, because you don't want to be caught, in order to get to where you want to go with HabWorlds, you need to beat down those TRLs now. So this is very exciting. We have a lot of people excited about this. And again, thinking about looking at Earth-like planets, this is a simulation from our solar system, right? So Jupiter is far enough away, but Earth and Venus require very careful control of the coronagraph, which basically just blocks the star in the middle of that solar system. In order to get the spectroscopy, that you need to detect the elements which might be biosignatures. So really getting that precise control is the key for detecting life. Okay, so just to give you a sense of what it might look like, here's 3 designs that are being considered. Just to, so one's very similar to Webb looking, right? And this is all going to be worked out by these teams. So there's an engineering team, there's a science team. We're all working on this, and we're just in study mode right now. But the good news is that Goddard established a HabWorlds technology office, and we're working on these problems now. So, all right, so let's talk about LISA. I guess I need to move faster. All right, so LISA is about detecting gravitational waves. And the one thing I want you to remember about LISA is, well, 2 things. It's a joint mission with ESA. So we're partnered with ESA. And we're doing a lot at Goddard. We're doing project science, we're building telescopes, lasers, and we're doing the ground segment. So a lot of LISA is happening at Goddard. And the LISA array, there's 3 large spacecraft. They're so far apart that essentially the sun can fit inside that triangle. So in order to be able to detect the waves, they have to be spaced so far apart that they can detect extremely small picometer type scales. All right. So let me move on to Earth science. What's next for Earth science? PACE is, PACE was launched a year ago. So it's not, but really now is when it's delivering the science. So PACE was built here at Goddard. The ocean color instrument is moving us from an era where we could only detect how green the ocean was. This is chlorophyll. And now we can detect what type of phytoplankton is actually present in the ocean. So going from just how green is it to species, and being able to model and predict the species and the evolution of the biogeochemistry of the oceans. That's what's new with PACE, and that's happening right now. So you're going to see a bunch of really cool things coming from PACE. There's also 2 other instruments. There's 2 polarimeters on PACE. One of those was built right here at UMBC. It's called HARP-2, and it actually measures aerosols and can distinguish between smoke and clouds and other things. All right, so This Jim will like this one. So Landsat Next. So Landsat, you know, traditionally has been a single spacecraft with a revisit time that was not enough for most applications, I'll just say. And so Landsat Next tries to solve this problem by having 3 spacecraft and by having multispectral capabilities, so adding much more resolution to the, step back. So much more spectral resolution. So the Landsat Next is compared to Landsat 9 in terms of its repeat. And then down here is just the more bands and more resolution. So more of everything. So the Earth System Observatory, this is the future of Earth. So those of you familiar with the Earth observing system, this is sort of the next concept behind that, the Earth System Observatory. There's going to be a gravity or mass change measurement. There's going to be a hyperspectral and a multispectral thermal. Hyperspectral will be square and multispectral thermal called SPG. And there is something called AOS, the Atmosphere Observing System, which does aerosols, clouds, convection, and precipitation. This is partnered with Japan as well as other countries, and I'll just say the details of this are still being worked. So we are working hard to at least deliver something that's sort of a follow-on to GPM, which would be the PMM part of this. But there's other things that are still being redesigned. All right, so let me finish up Earth science with this little nugget. So last year, NASA and IBM delivered something called PRITHVI, which is a weather and climate foundation model. And it was trained on something we call MERA-2. This is a reanalysis where they take all the satellite data and blend it with models over the entire period of record. And they use this to train an AI model. And that's what a foundation model is. Once you have a pre-trained foundation model, you can use it for other things. And this is just an example of what this foundation model would forecast versus what actually happened. This is for Hurricane Ida. So they went back and said, how good would this have done if we had tried to forecast a hurricane? And that's what this is. This is going to revolutionize weather forecasting. The European Center is already doing this. This is the future of weather forecasting. And I think you're going to see much more data-driven modeling in the future. Okay, so heliophysics. Last year was heliophysics big year. Did any of you see the eclipse? Anybody go to see that? Yeah, I did too. I locked out because I got to say, I went to the dumbest place. I went to Vermont, okay, because my friends had a house in Vermont. And we said, you know, it was in the path of totality, but I was like, oh, it's going to be cloudy, it's going to be terrible. You know, I was like, we should have gone to Texas. It was the reverse. So Vermont was beautiful and clear, and it was amazing. So anyway, but I just mentioned Parker Solar Probe had its closest approach. And really now we're moving towards these launches. So in April, we're expecting to launch Punch, which is a polarimeter. And it's actually a constellation. More missions. So I mentioned IMAP. It's actually launching together with Carruthers Geocorona Observatory, which used to be called GLIDE, if any of you remember that term, and NOAA's Space Weather follow-on to L1. So all of these are going out to L1, the Sun-Earth Lagrange point, L1, and they're going to go in a halo orbit around there, around September of 25. Okay, so let's go to planetary science. I just want to congratulate Maven. This is sort of a look back, but this has been a big deal for Goddard because this really tells us, again, if we can understand the evolution of atmospheres on planets in our own solar system and how space weather impacts the loss of atmospheres, that helps us understand exoplanets. So being able to understand our own solar system is key for the search for habitable worlds as well. So this is going to be super exciting. Have you all heard of OSIRIS-REx? I don't know how many. Yeah. So OSIRIS-REx went to asteroid Bennu, came back last year. I was there in the Utah desert when it landed. It's super cool. And the science is amazing. And there's going to be a big press release at the end of the month. So keep your eyes peeled and look on social media. We are looking for, you know, the building blocks of life. And so I think you look for that kind of a press release at the end of the month from OSIRIS-REx. And a lot of this analysis is being done right in Goddard in Building 34. So I'm very proud of that team. It's a cool mission. All right, so wrapping up, you know, the other thing that's happening for science is Science for Artemis. So we actually have 2 Artemis project scientists at Goddard. So Artemis 3 and 4 project scientists, Noah Petro and Barbara Cohen, are part of 600. And they're working hard on maximizing the science return of Artemis and what we can do you know, with astronaut-deployed instruments, with other instruments as well. And supporting not only the lunar science, but also we have a whole other group in heliophysics that is called the Moon to Mars Space Weather Office. And so they actually predict space weather anytime Artemis is operating. So we actually run these models and forecast space weather. Just like you get forecasts on your phone of weather, we're going to be providing astronauts forecasts on hypothetical tablets. So this is all happening at Goddard. So it's a really exciting time in supporting exploration. And then wrapping up with a few more. So this is happening this week. The Blue Ghost Mission 1, so there's a launch on the 15th, it's supposed to be on the 15th. Firefly, and there's a couple instruments from Goddard on there. Lunar landing. There's Lunar Trailblazer at launching, and then in April, Lucy, the Lucy mission, is going to do a flyby an asteroid, Donald Johansen. So that's another exciting thing. And I can't leave out Dragonfly and Da Vinci. So these are 2 really exciting missions. In fact, some press called Dragonfly like the coolest mission you'll ever see or something, right? Which is, you know, a rotorcraft flying to Titan. It's supposed to launch in 2028 and arrive in 2034. And we're not only, you know, working with our partners at Applied Physics Lab on this, but we have instruments being developed at Goddard. And then Da Vinci, tentative launch date, that's of course going to Venus in 2030, we hope. And we're waiting for, you know, budget issues to settle out for that one. So that is where science is going. And I think our future looks really bright. So it's an exciting time to be at Goddard. And I hope you will come visit. And I'm going to issue you a special invitation, this is my last slide, to our poster party. So every year, we have a poster party in January where we ask folks to, you know, display posters from recent science meetings like AAS, AGU, AMS. We invite you all to come. And we give some awards for best posters. And so Carl, I think, is going to work with you all, for those that might be interested, to attend. So I hope you all will be able to come. And thank you. How are we doing on time? Okay. Any questions? Yes, so Athena is going through its, what ESA calls it, it's not confirmation, it's adoption, right? And so so according to Rob, I was just talking with Rob Petrie about this, So there was a redesign to call it New Athena. Again, they were under cost constraints, so Goddard worked hard on that design and will be contributing technology to get it to meet the cost constraints that ESA has for that mission before it goes through its formal adoption. So we're working with them on that. The contribution is two things. And now, optics is one, but there was another one too. There was something about miniaturizing something. They were doing it at Marshall, but they're moving it to Goddard. But I'm sorry, I'm blanking on the specifics. I think so. So look for New Athena as it's being called, and that's in the process. Oh, sorry.
Yeah, I heard in Earth Science, I heard there's a new initiative coming out of headquarters. It used to be applications, now it's Earth Action.
Yes.
Can you talk a little bit about Earth Action and what it is?
Yes, so Earth Action is really an expansion of the applications program. If so having been in Earth Sciences, at the time, Lawrence Friedel was leading applications and Jack Kay was leading RNA. And there was a hard boundary between the two of them, right? So Earth Action is trying to be a little more inclusive and connect research with applications a little bit more so that I think the research is more applications relevant. Not all of it, but some of it, right? So it's trying to break that boundary and be more connected. So, yeah.
I have two sample questions. Do you have samples of the new in Building 34?
We do.
Wow, cool.
We had a tour, actually, we had an employee tour where people could come see the samples, which was very cool. I mean, you could, they were in a clean room, so you were looking through a door. But, but yes, there are samples of the new in Building 34.
And is there any engagement on the redesign or re-effort on Mars sample return?
Yes, so some of you probably know the Mars sample return had an RFI, and they just had the press release last week discussing two ways forward. One way forward is using, basically using a crane, a sky crane, to lower some of the mass down and then still doing something like the CCRS, but they didn't call it. That is still TBD about what that would look like and what Goddard's role would be. The other concept was more, commercial driven, I'd say. So, we were asked to provide some experts, some subject matter experts from CCRS, which was the containment, capture, and return systems that was canceled. So we had some of our experts providing input, but as of yet, the Goddard role is unclear for the future.
Are we part of the study team, or are we part of the study team now?
Our subject matter experts were asked to be part of the reviewed team. The study team, I think, is still TBD. I'm not aware of anyone from Goddard. At least from science, I'm not aware. There may be engineering people, but I'm not aware of that either. So, yeah. Yeah.
What percentage of
Sorry.
what percentage of the missions you described here are actually funded?
Yeah. Well, so Dragonfly is. Da Vinci is sort of in, it's funded, but it's in a sort of a slow roll, I guess you would say. I mean, I'd have to go back through. The ones that are most uncertain right now are, you know, the longer out ones, right? So, you know, all the ones I said that are getting ready to launch are completely funded, right? So you know, it's those further out ones. AOS is still subject to great uncertainty. I didn't even mention GDC. No one asked about that, but that's the Geospace Dynamics constellation in Heliophysics. But the Decadal Survey just came out and recommended that again. So, you know, I would say of the future missions, you know, maybe 2/3 are funded and 1/3 are not right now, or at least are maybe moving at a very slow pace. I mean, even GDC is still technically funded because we're still on CR. So that's the other part of this, right, is that we have to depend on the appropriations and wait for the president's budget, and, you know, much of that will be subject to the new administration, so we'll have to see. But the good news is, as I mentioned, those Decadal Surveys have endorsed all of these. You know, Da Vinci, and I haven't heard any. You know, the biggest risk is just timing of funding because of, you know, so I mean, let's be honest. The SMD budget, the Science Mission Directorate at headquarters, has taken an almost $2 billion cut. Okay, to the top line. Okay, so this is in the last few years, right? And you just added up, and it's about $2 billion, less than they thought it would be. And so that means that things they thought they were going to do are hard to do. So headquarters has to manage that. And they're making decisions, like, and that's why they ask for MSR, Mars sample return, you know, new ideas. And I think that's going to be the mode, you know, in HabWorlds, you know, there's no wedge. I mean, at the NASA town hall yesterday, Mark Clampton said, you know, there's no wedge for HabWorlds. There's a wedge for exoplanet science, and Roman is actually inside that wedge, if you look at the sand chart. And so as Roman winds down, that opens up space for HabWorlds, if that wedge remains. So I think that's, I mean, it's a kind of a long-winded answer, but it's complicated. So, yeah. So, we're still doing a lot of amazing science, right? Despite that, you know, that cut to the top line. And I think, you know, we have to be optimistic, and, you know, I think it's really important that we talk about how important the science is and the impact of it. So that's what we're doing when we get the chance.
Any other questions?
Consider a speaker.